About 100 years ago, these two men, Thomas Edison, the greatest practical engineer of his time, perhaps of all time, and his chief scientist, Charles Steinmetz, worked to develop powerful batteries. You're looking at the battery-powered car that Charles Steinmetz made back in 1914. Steinmetz and Edison passionately believed that battery-powered cars like this could compete with and beat gasoline-powered cars. But obviously, they did not. This is our GE Global Research Center near Albany, New York, where during 2 days in October 2008, we brought together battery leaders from around the world to discuss 21st century solutions.
Hi, I'm Tom Wolf. I'm from VSA Partners in Chicago. I'm here to learn about battery technology.
I'm Axel Krieger. I'm from McKinsey. And I was working for a long time in the automotive industry before, and I strongly believe in electric vehicles.
I am from Saft in France, and my company is making batteries. That's why I'm very pleased and interested to be here.
We're building some hybrid vehicles in prototype stages, and we're looking for new battery technologies that we might be able to use for our systems.
It's a long way to come here, but I think it's very important to have this. I hope to get also a global view of the battery market.
You look at GE technology.
Mark Little, our Senior Vice President of Global Research, provoked the audience by showing how rapidly the world's energy demands are growing. Speakers and attendees dialogued about possibilities, and many points of view were presented.
Hi, I'm Sven Thiessen from Better Place, and we have a mission, and that mission is to end our oil addiction in the transportation sector.
My organization is responsible for all the ground vehicle systems, both combat, tactical vehicles, water purification systems, anything that moves on the ground.
Given that I'm from Norway and Norway has harsh winters, we have gained some experience with the first 1,000 cars we produced in Norway, how it is in the wintertime. And actually, it's not too bad unless you put the heat on full speed, and you obviously get a little bit less range.
Is this system battery pack safe when it's not powered as well as when it's powered? Some battery technologies and chemistries aren't always even just safe when they're not powered.
If you look at energy and utility companies, consumer electronics, all these other industries is where innovation is going to happen.
I think this conference brings together an extremely interesting group of people. You know, obviously you've got GE, one of the major global infrastructure players, and we believe infrastructure is going to be a core driver of this next wave of growth.
The devil's in the details. How do you...
If solutions were easy, scientists would have come up with the answers by now. But it's extremely difficult to make batteries that provide the required power output, energy storage, and safety while taking into account constraints in size, weight, and cost.
Yeah, that's a right model. Where is the research competence? Where is the competence of choosing the right batteries?
That's us. Because the story is non-linear. Like, I believe half a megawatt up and down is going to be the same.
I mean, it's not all there to compensate for the load variation.
But if it were to be 30 megawatts either way, that's it.
They'll be talking to us in there.
To encourage dialogue, we took the attendees on a behind-the-scenes tour of our battery labs.
We've done a lot of ceramics and materials technology for our lighting business, and in the lab we're going to walk into now is one of our advanced research battery laboratories.
At GE, we are working on energy solutions that use wind, solar, nuclear, and clean coal technologies, and on battery power solutions for locomotives, tanks, buses, mining vehicles, as well as cars.
Welcome to EP Building, and this is a great place where we test all sorts of drives, batteries, and systems. This vehicle is being introduced in Europe right now, and it's going to be having 3 batteries, a sodium battery, which is standing behind you on the ground, and 2 lithium batteries, one made by Enerdel and one made by A123.
They're only going to choose one, right? I mean, you're testing 3 batteries.
No, the thing is having 3 suppliers deliver batteries to them so they can meet their production numbers. Because if you haven't checked it out, you can't buy a battery like that at Radio Shack.
but you'd be able to send somebody a warning when their charge was getting low and things like that.
Right, or your cell phone might ring and say, hey, your car's just been quick charged, it's parked outside, and you're ready to go to your Aunt Bertha's for Thanksgiving. I don't know. But there's going to be a lot more interaction between your car and yourself through communications, through internet, and it's going to be very exciting.
This is where the active chemistry actually takes place, is in one of these cells. And then depending on the application, we can put them in parallel and series to any size that we want. It is a high temperature battery. The cells themselves operate at about 300 degrees C. In a battery pack, which you see here, this is a small one. So this has about 20 of these cells. You can put your hand on it. This is actually live and it is running. The outside temperature gets too warm or too cold, they don't operate very well. You're probably all familiar with trying to crank your car on a cold day with lead acid batteries. Same is true, for instance, with lithium chemistries. It gets too cold or too hot, they don't operate very well. This actually is the size of one of the batteries for our hybrid locomotive, which is essentially another hybrid car.
That's how we address this problem. We bring in the right resources, and we're very fortunate because we have such a diversity of expertise here.
Well, I think it's really exciting that there are partnerships developing between entities that have the real research power and capacity that General Electric does, with these companies that have a very long history in turning out cars.
The conference was intended to provoke dialogue, and as we had hoped, startup companies used it to make announcements and to build buzz.
Last night I'm pleased to announce that Australia, a rather larger country than Denmark and Israel, joined the fold.
There's a lot going on right now. It's a very dynamic environment where standards are in flux. There's a lot of competition going on, and it's very much a capitalistic kind of competition.
I think battery technology is a really important part of the future, in the sense that you're looking at more renewable energy for the grid. When you're going to vehicles, you're looking at more electrification of the vehicles. That comes back again to having more energy storage capabilities.
We're in a place right now where the electrification of our world really is going to give us a handle on how to address some of the bigger global problems that we have. We talk about wanting to drive to oil independence, and I think there's a lot of merit behind doing that, and battery technology can help enable us to diversify and better utilize our sources of energy.
It took Thomas Edison 8 years and 10,000 experiments to build a storage battery that worked. A newspaper reporter asked him how it felt to fail at something 10,000 times. Said Edison, "You don't understand. I haven't failed 10,000 times. I simply succeeded at finding 10,000 ways that don't work." And that is how we see things today. The answers are out there, and battery technologies developed by companies from around the world will succeed at building powerful, usable, greener, cleaner, sustainable battery solutions.